Okay. Cedar Girls 2024 prelim question 1. Okay. Two cylinders are such that the ratio of their heights is square root 7 is to 1. Okay. The height of the smaller cylinder is 2 root 7 minus 1 over 2 minus root 7 squared. Okay. Without using a calculator, find the height of the larger cylinder, expressing our answer in the form a plus b root 7, where a and b are integers. Okay. So root 7 is 2.645, so which is larger than 1. So that means this is supposed to be big, and this is supposed to be small. All right. Okay. So if the height of the smaller one is this thing, right? So that means the larger height would just be this number multiplied by root 7. So 2 root 7 minus 1 over 2 minus root 7 squared multiplies by root 7. Okay. So we'll have 14 minus root 7 over expansion of the bottom, a minus b bracket square. So we'll have a square minus 2ab plus b squared. So that would be 11 minus 4 root 7. Okay. To rationalize this, I need to multiply by 11 plus 4 root 7 over 11 plus 4 root 7. Okay, so that will give me 11 squared minus 4 root 7 squared. All right, 4 root 7. Okay, over 3. Is it? 4. Okay, so again, 11 squared minus 4 root 7 squared. Okay, so that will be over 9. Okay, so remove method for the two extension. Okay, 14 times 11. Okay, 154. Okay, plus 56 root 7 minus 11 root 7 minus 28. Okay, so 154 minus 28, that will be 126 plus 45 root 7 divided by 9. Okay, so 126 divided by 9, that will be 14 plus 5 root 7. Question 2. The profit y of a company can be modeled by the equation y equals to a bracket x minus h squared plus k, where x is the number of goods sold, a, h, and k are constant. Okay, so y represents profit, x is the goods sold. Okay, the company obtained the maximum profit, okay, of 24,500 when 800 goods were sold. Okay, so that means a few things that we can gather down here, right, is that since it's a maximum, so the a must be negative. Okay, so y equals to whatever it is, right, is going to be a set curve because it's a maximum point. Okay, and the maximum point is 4,500 on the y, right, 24,500. Okay, now when 800 goods were sold, so x equals to 800. Okay, so the maximum point is 800, 24,500, something like this. Okay, now the company incurred a loss of 7,500 when no goods were sold. So this actually is also important. Okay, so it means that this is when no goods were sold, means x equals to 0, y equals to negative 7,500. Okay, state the value of h and of k. Okay, so based on this, I'm supposed to find h and k, which yes, I can because I have the turning point. Okay, and we know that y equals to a bracket. The turning point is determined by the x value down here, negative 800 square plus 24,500. Okay. Now, using the values of h and k, find the values of h. So now, when a equals to when x equals to 0, y equals to negative 7,500. So negative 7,500 equals to 0 minus 800 squared plus 24,500. Okay, so shift it over, right? Shift the 24,500 over. So we have negative 7,500 minus a further 24,500. So we have negative $32,000 equals to 800 squared. So A equals to negative 32,000 divided by 800 squared, which equals to negative 0.05, or as I mentioned, negative. Find the range, the number of goods the company needs to sell, okay, to earn a profit. Okay, so to earn a profit, that means we don't want to do. So our y must be greater than 0. So now that we have the equation is y equals to negative 1 over 20 x minus 800 squared plus 24,000. Okay, so let's find out where is the breaking even. Okay, the point where we are equals to 0, okay, when it's equals to 0. So for it to equals to 0, okay, so in other words, we want to be more than 0, right? So negative 1 over 20 x minus 800 squared plus 24,500 will be more than 0. Bring the 24,500 over, so x minus 800 squared. Okay, it must be greater than negative 24,000. Okay, divides by the negative 1 over 20. And so we'll get x minus 800 squared must be less than 4 square root of sides. No choice, bring it over and bring it over. So x minus 800 squared minus 400 must be less than 0. Okay, so this reminds us of, okay, whether a square root of 9 or 400. Okay, I think we can write that. Okay, that's 700. So then this will have this, this is actually our a square minus b square. Okay, a square minus b square. So we can have x minus 800 plus 700, x minus 800 minus 700. Okay, must be less than 0. So that means we have x minus 100 or x minus 1,500 must be less than 0. So inequality, okay, we should use our middle. Okay, as far as inequality goes, okay, so we have to draw a line. Okay, the two roots are 100 and 1005. Okay, and it's a small face. So that means less than 0, x must be less than 1005, more than 100. That's it. Okay, find the range in order to earn it. Okay, logs. Right. Solve the equation 2 log 3p plus 1 over log 27 3 minus 1 equals to log 3 8p plus 1. Okay, so this question is about okay, so what we notice, okay, what we can notice is that it's all log 3, log number, log 3. Okay, so there's no unknown in the base, which is a good thing. Okay, so that means this question will be about cancellations of logs on both sides. Okay, so lots questions, okay, the idea of it, okay, the way the question is asked is pretty standard. Okay, so now over here we'll have 2 log 3p plus. Okay, now change of base for this, right? Okay, if you understand change of base enough, you can actually just change this into log 327. Now otherwise, okay, look over here, I can do this as well. 1 over log 27 3. Okay, when I do change of base, it'll be 1 over, so okay, 1 over log 3 over log 327. Okay, so that would mean 1 divided by 1 over log 327, which is log 3 cubed. Okay, so that means this answer will be equals to 3. Okay, which you put it back here, right? Okay, this will just be the same thing. Minus 1 equals to log 3 8p plus 1. Excuse me. All right. Now, so log 3p plus 3 minus 1, okay, equals to log 3 8p plus 1. Now we can simplify this a little bit, because 3 minus 1 is equals to 2. So that means I will have 2 log 3p plus 2 equals to log 3 8p plus 1. Now, the idea of cancellations is that the left hand side and the right hand side must only have one set of log. Okay, so over here, I can simplify this portion further by changing the 2 into this log 3p squared plus log 3 squared, okay, equals to log 3 8p plus 1. So this will become 9p squared. Okay, let's jump to my step. Okay, logarithm loss, this 2 will become log 3 9p squared equals to log 3 8p plus 1. So we're able to get this away. So we have 9p squared equals to 8p plus 1. 9p squared minus 8p minus 1 equals to 0. Okay, so factorize. Okay, so negative plus. So p equals to negative 1 of 9, or p equals to 1. Okay. But p cannot be negative because p exists as an argument. Okay, this is an argument meaning the, okay, when we talk about indexes, right? Okay, this is the base, this is the index, okay, 8 is the argument. Okay, the result of it. So right, this number cannot be negative. Alright, so therefore p equals to negative 1 over 9 is rejected. Okay, question 4. Solve the equation 5 to the power of x plus 1 equals to 5 to the power of 2x minus 1 minus 30. Okay, looking at this question, okay, the first thing that must come to your mind is that 5 to the power of x and 5 to the power of 2x. Okay, such question, substitution, right? Okay, so splitting of indices, okay, we talked about this before, right? 5 to the power of x plus 1 will be 5 to the power of x times 5. Okay, equals to 5 to the power of 2x times 5 to the power of negative 1 minus 30. Okay, so let 5 to the power of x be y, for example, or u, or whatever alphabets. So we'll have over here 5y equals to 1/5 y squared minus 30. Multiplies by 5 throughout, y squared, and then I bring them over to the right hand side. Okay, y squared minus 25y minus 150 equals to 0. Okay, so jump a lot of steps down here. Okay, so make sure you can understand the jump of the steps. All right, so now factorize. This one looks to be 30 and 5, right? So y, okay, minus 30 plus 5. Okay, equals to 0. So y equals to negative 5, or y equals to 30. So that means 5 to the power of x equals to negative 5. Don't get tricked. Again, exponents cannot have negative. So this part has to be rejected. Okay, and then we have 5 to the power of x equals to 30. To solve for x, take ln at both sides, or take logs if you want to. That's the same. So x log 5 equals to ln 30. X equals to ln 30 divided by ln 5. Okay, ln 30 divided by ln 5. Okay, 2.1133. Right, so 3SS 2.11. Question 5. Given that y equals to x cubed minus px squared minus 45x plus 10 is decreasing for x less than q more than negative 3. Find the value of the constants p and q. Okay, so we are finding two unknowns. Okay, to find two unknowns, we probably have to have two equations in order to solve for it. Okay, but what is this question about? Okay, so we have a function that is decreasing. Okay, so for a function to be decreasing, it means that the dy dx is actually negative, less than 0. Okay, so first, y equals to x cubed minus px squared minus 45x plus 10. Okay, dy dx is equals to 3x squared minus 2px minus 45. Okay, now for dy dx to be less than 0, okay, okay, so we can see that okay, this part down here, this is an inequality range. Okay, so to dissect this inequality range, okay, so that means that there is this something like this. Okay, there's a root of negative 3 and q, and then because this is 3x squared, so that means it's a small face. Okay, and then we are considering the inequality down here. Okay, so to put it into perspective, right, this will give me an equation of something less than 0. Okay, something less than 0, and the two roots, right, can be rewritten as x plus 3 and x minus q. Okay, right, but x and x only gives me x squared. Okay, I need to have 3x squared, so I need to put in another 3 multiplier of 3. Now, if I were to extend this, okay, I'll get 3 bracket extend inside first, x squared plus 3x plus 3 minus q x minus 3q. Okay, to be less than 0, bring in the 3 as well. 3x squared plus 9 minus 3q x minus 9q. Okay, must be less than 0. Now, my dy dx over here, okay, so this should be my dy dx. So that means that these two things are comparable. Okay, comparable. Okay, so from there we can draw a conclusion that, oh, that means negative 9q must be equals to negative 45. Okay, so Q equals to 5. Okay, then solve for P. Negative 2P must be equals to 9 minus 3 times of 5. Negative 2P equals to negative 6. Okay, so P equals to 3. Okay, question 6. The graph y equals to a plus b cos cx is defined for x is less than or equals to 2 pi, more than or equals to 0, where a, b, and c are constant. The graph has a period of 4 pi over 3 and a minimum value of 1 when x equals to 4 pi over 3. Okay, so the graph also passes through the point pi over 3 and 3. Show that a equals to 3, b equals to negative 2, and c equals to 3 over 2. Okay, so they switch up the order a little bit uncommon, okay, from what we are usually used with. Okay, but we don't understand the principle behind it. A is our vertical sheaf, okay, or our middle line. Okay, B is our amplitude in this case. Okay, usually it's A, but this time it's B. Okay, and C represents the number of cycle. Okay, in 360 degree, or in this case, in 2 pi. All right. Now, our graph has a period of 4 pi over 3. So if you are unfamiliar with radian, okay, usually I will do this is that, okay, we have to understand that pi is 180 degree. So 4 times 180 degree divided by 3, okay, 240. So what does 240 degree means? Means that every time it reaches 240 degree, I will have one sine curve. That's what the cosine curve. Okay, that's what the period means. Okay, means I will have a cycle in 240 degree. So if I go up to 360 degree in this case, okay, I will have 1.5 cycle. Okay, because one cycle in 240 degree, half a cycle is 120 degree, right? So since the 1.5 cycle is the in 360 degree, so therefore C must be equals to 1.5. Okay, so to solve for C, I can just say that is 2 pi, right? 4 pi over 3. Okay, 2 pi divided by 4 pi over 3. Okay, so that will be 3 out of 2. Okay. Now, then the next thing that we need to find here is that when x equals to 4 pi over 3, it is actually a minimum value. Okay. So this one goes back to our cosine understanding of a basic cosine graph, right? Okay. A basic cosine graph will go from positive, okay, to start from the max, goes to the mean, then goes back to the max. So by right, when it completes one cycle, it's actually at the maximum. But this time around, when it completes the cycle, it was actually at the minimum, which gives me a hint that the graph is actually going the opposite direction. Okay. So that will also means that our amplitude, even the amplitude is positive value, okay, our b is actually negative. Okay, so next thing to note is that the graph also passes through the point pi over 3 and 3. Okay, now since because I know that the value of C is 3 over 2, right? So 3 over 2, I multiply by pi over 3, which is 180 divided by 3. Okay, I do it in degree. So that's 90 degree. Now cosine 90 is equals to 0. Okay, but if it's cosine 0 and the answer shows me it's 3, right? Because when cosine 0, the answer should be 0, okay, as in the middle line. But this time out is 3. So that means the middle line is equals to 3. So therefore, okay, cosine, right, like this, cosine 3 over 2 multiplied by pi over 3 must be equals to 0. Okay, so if it's equals to 0 and there's a 3, so that means a plus, okay, is equals to plus cosine 3 over 2 times pi over 3 is equals to 3. Therefore, a must be equals to 3. Okay, sure. So this one is to prove. Okay, now b must be equals to negative 2, where that came about, because the minimum value of 1, right? So that means that when 3 plus b cos 4 pi over 3 times 3 over 2 equals to negative 1. Okay, so this is supposed to be 1, right? So 3 plus b bracket 1 equals to negative 1. So 3 bring over b equals to 1. So b equals to negative 2. Yeah. All right. So sure. Sketch the graph of y equals to a plus b cos cx for x less than 2 pi and 0. Okay. So the origin is drawn for me, the angles are drawn for me as well. Okay. So that is good. Okay. So what will happen is that, okay, I'll label 1, 2, 3, 4, 5. Okay. Now this line is actually important because this is the middle one, right? Now, however, this is negative cosine, so the note is started off at the minimum, okay, closest at the minimum, right? So in between, this is one cycle. So one cycle break off into 4 different points. Okay. So then we'll have cosine goes to 0, goes to top, goes to 0, goes back to bottom. So we'll have something like this. Okay, and then continue as well. This is half a cycle, so it's like this. Right. So this is our cosine graph. Okay. Given that there are exactly 3 solutions for the equation b cos cx equals to k minus a, state the range of the values of the constant a. Okay. So now this question, when I shift the negative a back, so I'll have a plus b cos cx equals to k. Right. Now to have 3 solutions, okay, what must happen? Okay. So this is just a single value k, right? Y equals to k. So it is a horizontal line. Now, if I place my horizontal line over here, there's only 2 solutions. Okay, but the moment that I shift this line a little bit up, then there will be 3 solutions, and this will always remain as 3 solutions within here until I reach the top again. Then there will only be 2 solutions. Further, no solutions. Further down, no solutions. So it's in between this range that you will have 3 solutions. So that means the k value must be less than 5, greater than 1 to have 3 solutions. Okay, question 7. The graph of dy dx of a function y equals to fx is shown in the diagram passing through the x-axis at negative 2, 0, 0, 0, and 2, 0. State the number of stationary points on the graph y equals to fx. Okay, so stationary points of y equals to fx is when dy dx equals to 0. Okay, so now this question is a little interesting because it's not plotted y against x, it's plotted dy dx against x. So when dy dx equals to 0 means I'm looking at this line, right? The x-axis line. So we have 1 point, 2 point, 3 points. So therefore, the number of stationary points, there are 3 stationary points. Okay, state the x coordinate of the minimum point of y equals to fx and explain why is it the minimum point. Okay, now minimum point, right? What does it mean? Okay, means that the graph is a negative gradient, goes to 0, and then goes back up to positive. Okay, that will be a minimum point. Now, but we have to take note that this is against dy against x. Okay, so when the gradient is increasing, okay, down here, okay, at this point, at this moment, before here, right, dy dx was negative. Okay, but above here, after the point 2, dy dx is positive. By looking at the y-axis, the dy dx axis, right? Okay, can you see this is negative to positive? So negative gradient to positive, therefore the minimum point is x equals to 2. Okay. The curve y equals to ax plus b over 2x minus 1 cubed, where a and b are constant, has a stationary point at 3, 2, and 11, 2. Find the values of a and b. So what I'm taking off this question, right? Since they mentioned stationary point, so that means dy dx equals to 0 when x equals to 3 out of 2. Okay. Now, and then since they say find the values of a and b, there are 2 unknowns. 2 unknowns means I need at least 2 equations to solve it. Okay. Right. So first equation, I start in the 3, 2, and 11, 2 directly into the equation. So I'll have when x equals to 3 out of 2, y equals to 11 out of 2. So 11 out of 2 equals to ax. A bracket 3 out of 2 plus b over bracket 2 times 3 out of 2 minus 1 cube. Okay, so simplify, that will give me 3 out of 2a plus 1 out of 8b equals to 11 out of 2. Okay, multiply by 8 throughout, I will get 12a plus b equals to 44. Equation 1. Okay, so I need another set of equation in order to solve simultaneous for it. Okay, so now I have to differentiate because that's dy dx. So y equals to ax plus b bracket, what I'll do down here, change it into 2x minus 1 to the power of negative 3. So dy dx equals to a plus minus 3 bracket 3b bracket 2x minus 1 to the power of negative 4 multiplied by 2. So then I will get a minus 6b bracket 2x minus 1 to the power of negative 4. Okay, so in x equals to 3 out of 2, so I'll get when x equals to 3 out of 2, dy dx equals to 0. So a minus 6b over, okay, 3 out of 2 times 2 is 3, 3 minus 1 is 2, 2 to the power of 16. Okay, a minus 16, 6b over 16 equals to 0. Cross multiply if you want to, so 16a minus 6b equals to 0. Equation 2. Okay, so over here, right, we can do whatever you want to do substitution, elimination, both is fine, right? Okay, for me, I prefer, okay, for linear equations, I prefer to do elimination. Okay, so over here, what can I do? I can just multiply by, multiply by 6. Okay, so I'll get 72a plus 6b equals to 44 times 6, 264. Okay, 16a minus 6b equals to 0. Okay, adds up both sides of the equation, so I get 88a equals to 264. A should equal to 3. Okay, nice number, 3. Oh, so 16a minus 4, 6b equals to 0. So 16 bracket 3 minus 6b equals to 0. 6b equals 48, and b equals to 8. Let's probably find the x coordinate of the other stationary point. Other stationary point. When dy dx equals to 0, find dx equals to a minus 6b. So a is 3. Okay, let me just write down. Okay, dy dx equals to 3 minus b is 48. Okay, 6b, sorry, right? 6b over 2x minus 1. 2x minus 1 to the power of 4. Okay, now dy dx equals to 0. So we have 48 over 2x minus 1 to the power of 4 equals to 3. Okay, so we have dy dx equals to 0. Okay, cross multiply, and we'll have 2x minus 1 to the power of 4 equals to 16. Okay, so root 4, 2x minus 1 equals to plus minus 2. Okay, when I take the root 4 on each side. Okay, because this is even power, I will have plus minus. So 2x minus 1 equals to 2, 2x equals to 3, x equals to 3 out of 2. This is our first term, so we'll get it. Okay, or 2x minus 1 equals to negative 2, 2x equals to negative 1, x equals to negative 1. Answer. Okay, because they're asking for the other stationary point. Okay, find d2y dx squared. So d2y dx squared will be, okay, dy dx equals to 3 minus 48, 2x minus 1 to the power of negative 4. So d2y dx squared equals to 48 times 4, 192 bracket 2x minus 1 to the power of negative 5 multiplies by 2. So we get 192 times 2 further, 384 bracket 2x minus 1 to the power of 5. Okay, hence determine the nature of the stationary point at 3 over 2, 11 out of 2. Okay, so when x equals to 3 out of 2, d2y dx squared is equals to 384 multiplied by 3 minus 1 to the power of negative 5. So that will be 384 divided by 2 power of 5. Okay, equals to 12. Since, okay, so therefore, since d2y dx squared is greater than 0, therefore it is a minimum point. Okay. The diagram shows a running track ABCD. D is a point on the straight line EC. And it's given that AB equals to 280, AD equals to 150. Angle BCD equal angle DAB equals to 90 degrees. Angle ADE equals to theta, where theta is less than 90, more than 0. Show that the length of the running track is given by the formula, where P is a constant. Now, looking at this question, okay, there are a few things that we need to understand from it. Okay, firstly, is a formula, right? Now, this one is definitely something related to our formula. Okay, so number one, you need to be able to identify the question. Now, 130 and 430. Looking at the numbers itself, okay, you need to be able to realize that 130 is actually the result of. Okay. Now, sometimes the question is direct, the numbers are just out there. But in this case, right, you need to realize that 130 is 280 minus 150. And 430 is actually 280 plus 150.
All right. Okay. So that's number one. Number two, right, is that the angle theta that is given to me lies outside of the straight line. Okay. So now my consideration is what is on the line on the inside, right? So this is 180 minus theta. Okay. So then, all right. The thing is, we need to realize what is angle ABC. Okay. Now angle ABC is equals to theta. Why? Right? Because inside this figure, ABCD is a four-sided figure. So four-sided figure, total angle is equals to 360. Now, but we already have two right angles, which is made up of 90 plus angle ADC plus angle ADC. So that means these two angles, right? These two angles must add up to 180 degrees. Okay, so that's why angle ABC must be theta. Oh, must understand this part. Now, third thing is that the right angles that in our formula, the right angles that they give us, right, most of the time it is useless. Okay, what we need to do with it is we need to cut it. Okay, so draw a line parallel from A. Okay, a parallel line that cuts through A that is parallel to EDC, right? Okay, so remember to state that as well. Okay, let's call this point Y. Okay, so let Y be a point on BC such that AY is parallel to BC. Oh, let's put in a statement like this. Okay, now okay, let's switch the statement to be over here, right? So that we have more space for working. Okay, now secondly, I will have another line, right, that cuts through. Okay, let's say let X be a point on AY such that XD, okay, let's call it point X, such that XD is parallel to YC. Oh, now saying this, right, and labeling on the diagram, okay, that will be good enough because you explain these two alphabets. Okay, now to find the parameter of the shape, okay, what do you need to add? You need to add the 150 plus the 280. So actually that's the value of the key already, right? Okay, now and then you have this part down here, okay, this part over here, this BC and DC, which we don't know yet, okay, so we are able to find. So based on the fact of the theta, right, so based on the fact that the theta, okay, so that means that this angle will be 90 minus theta. And since this is 90 degrees, right, which means that this angle must be theta, right, angle DAY must be theta. Oh, okay, so then now we can start off with the question. So based on the triangle, okay, DAY, right, in triangle DAY, we can see that sine theta is equals to AY over 280. Okay, so AY equals to 280 sine theta. Okay, now same thing, cos theta is equals to DY against 280. Okay, so DY equals to 280 cos theta. Okay, so that's two things. Now, then based on the triangle AXD, okay, we can have sine theta equals to XD over 150. So XD equals to 150 sine theta. Cos theta is equals to AX over 150. So AX equals to 150 cos theta. Now, then notice that XYCD is a rectangle. So DC is actually equals to, okay, parameter, we can add already. So parameter is 280 plus 150 first. Okay, plus DC. What is DC? DC is actually AY minus AX. AY is 280 sine theta plus 280 sine theta, but minus 8ax, which is minus 150 cos theta, right? Plus BC, which is BY plus YC, right? BY is 280 cos theta, right? Plus 150 sine theta, right? Plus XD, right? XD is 150 sine theta. Okay, so then you'll get your result of 430 plus 430 sine theta plus 130 cos theta. Sorry, switch things around. Okay, so switch that position because that's what the question gave us. Okay, sure. Right. Express L in the form of P plus R cos theta minus alpha, where R is greater than 0 and alpha is an acute angle. Okay, so L equals to 430 plus, okay, our formula cos theta minus alpha is cos theta cos alpha plus sine theta sine alpha. Okay, so that means the 430 plus square root 430 square plus 130 square bracket cosine, okay, R bracket cosine theta minus tan inverse sine over cosine, so 430 over 130. Okay, so do it in one step. So 430 plus square root 430 square plus 130 square. Okay, so that will be okay, 10 root 2018. Okay, by right, I should just actually, you know what? So let's change that. Okay, because your school calculator won't be able to do that. 430 squared plus 130 squared. Okay, so square root 201,800 cos okay, tangent inverse 430 over 130. Okay, so equal minus 73.170. Okay, which is equals to 430 plus square root 201,800 cos theta minus 73.2 degree. Oh, angles 1 degree. Okay. Sing King ran 5 complete laps around the track. She claims that she ran a total of 5 km. Explain why she might be wrong. Okay, let's see, right? This is in meters. Right, meters. So, okay, square root, okay, P equals to 430 plus square root 201,800. Now it's time to find out 201,800. It's 449, right? So it's about, okay, it's about 449.221 cosine theta minus 73.2. Okay, so then we have to explain, right, that cos theta minus 73.2, we know that this is something to do with the maximum minimum, right? So less than, more than -1, less than equals to 1. Now if I multiply 449 and plus 430 to it, so 449.221 will be less than cosine theta minus 73.2, then it multiplies the range into 449 as the maximum, 0.221, and the negative 449 as the minimum. Okay? But we know the parameter can be negative, right? So we need to add 430 to it. So add 430 to it, okay? Now plus 430 449.221 cos eta minus 73.2. So that must be plus 4.2 as well. So 879. Okay? So that means the maximum of one round, right, can only be 879, right? So actually, you know what? Let's remove the negative signs because parameter cannot be negative. Okay, then yeah, then this explanation will make much more sense. Okay, so then 5 times 879.221 is less than 5,000 meter. Therefore, same thing is wrong. Not my wrong, is definitely wrong. Okay, now, given that the running track is 700 meters long, find the value of meter. Okay, so we have 430 plus 449, and so here I actually want to use the exact square root 201800 cosine eta minus 73.2 equals to 700. Right? Bring them over. So that cosine eta minus 73.2 is on the left is equals to 700 minus the 430 divided by the square root 201800. Okay, so now I'm ready to take the cosine. Now remember, eta must be within more than 0, less than 90, right? Okay, so then right now over here, cosine is positive, okay, because everything is positive right now. So that means cosine will lies in the first quadrant and the fourth quadrant. Okay, so cosine inverse, okay, if I take 700 minus 430 divided by square root 201800, okay, 0.60103. Okay, so eta minus 73.2 is equals to cosine inverse answer, okay, 53.05, okay, or okay, 360 minus answer 306.944. Now, however, right, if I were to solve for the eta in this case, okay, I will bring the 73.2 to the right hand side, okay, and then you have to consider, right, if I bring the cosine to the right hand side, theta will be 53 plus 73, which is 120 something, or 306 plus 70 something, which is also 370 something. So that is wrong, right? Because eta can only be what's that? It must be in between 0 and 90. So we have to consider one more angle actually, right, which is the negative angle. So cosine, since it's in the fourth quadrant, okay, it can also go anti-clockwise. Okay, I mean, it can go clockwise. So the 306.944, I'm going to minus 360 to it. Okay, or it can be negative 53.055. Okay, or 0.5 good enough. Okay, now then it makes sense for theta to be equals to 53.05 plus 73.2, which is 126.3 rounded off degree, which we reject. Okay, 306.944 plus 73.2, which we also reject. 0.11 we reject. Okay, and the last one, negative 53.05 plus 73.2, 20.1. Okay, 20.2. 1.5 off, 20.2 degree. Okay, yeah, so this one is the answer of the set. After n years, the population P in thousands of a certain species of foxes can be modeled by the equation P equals to AEKN, right, where A and K are constant. On the grid on the next page, plot ln P against n and draw a straight line. Okay, so the question already tell you what axis to use, ln P against n. So then that means I need to take ln, right, okay, on the equation. P equals to AEKN. If I take ln at both sides, ln P equals to ln bracket AEKN. Now, separate them, that would be ln P equals to ln A plus ln EKN. Ln E will cancel off, so that means it will be ln P equals to NK, or rather Kn, plus ln A. Okay, so that my equation is in y equals to mx plus c. Now I plot ln P against n. So k is my gradient, ln A is my y-intercept. That's all, simple. Okay, use your graph to estimate the initial population of the foxes and the value of k. All right, okay, but first I need to draw the straight line graph in order to do that. Okay, so copy, goes to the next page, paste. Okay, scale is given to me, I like it. All right, now since I'm plotting ln P against n, so what is important is that I have the data called ln P. Okay, so roughly 7,934. Okay, so ln P, create a new table for ln P, right? So ln 6.23, I'll get 1.829, right? 1.82. Since they put 2 decimal, I also put 2 decimal. Okay, ln 6.23, then do 8.83, 1.83 together. 1.83. Then this one, ln 4.85, 1.58. Okay, ln 3.78, 1.33. Okay, ln 2.94, 1.08. Okay, ln 2.29, 0.83. Okay, so now we can plot the values. Okay, so since they started from 0.5 actually, right? So here increase how many blocks? 5, 10, 15, 20, 25 blocks. Okay, 25 blocks for 0.5. Okay, for 0.5. So one box actually carries 0.5 divided by 25, 0.02. Okay, so then over here, scales, right? This is 15, 5, 10, 15, 15 box. Okay, but this one, the value, and it should be okay, right? Okay, so now the first value is 6.2, okay, 1.83. So 1.5, okay, then 5 box will be, right, 0.1, so 1.6, 1.7, 1.8, 1.9, 1.8, so 1.8, 2, 4, right, 1.84. So that means 1.9, 1.8, 1.82, 84, will be somewhere here. Okay, 1.58 would be 10, 1.5, 2, 4, 6, 8, somewhere here. Okay, 1.33 at 15, so 1.5, 1.4, 1.3, 1.33 somewhere here, right? Then 20 is 1.08, 1.08 is over here. 25 is 0.83, 0.9, 0.8, 0.83 somewhere here. Okay, looks a bit, okay, more of a big cake. This one's a bit off, okay, because it's wrong, right? Because I put wrong position. Okay, let's go again. 20 is 1.08, 1, 2, 4, 6, 8, not looks like that. Okay, so now my straight line graph looks like this. Okay, so make sure that you draw long enough so that it cuts the y-intercept. Okay, this looks good, right? So next thing, what do I want to do? I want to find the initial population. Initial population of fox means when, okay, means when n equals to 0, right? So when n equals to 0, the value of the y-intercept is okay, 1p equals to, this is 2.020407, right? Okay, so it's 2.07. Okay, right? Okay, initial population. Okay, ln A equals to 2.07. So A equals to e to the power of 2.07 thousands, right? P is in thousands, so it's equals to e to the power of 2.07. Okay, so 7.924 thousandths. Okay, find the value of k. K is the gradient, so I'm going to take 2 points. Okay, the 2 points, right? Let's say I take, what point should I take? Okay, I'll just take the 2 coordinates one half. Okay, so k equals to y2 minus y1. So let's say I take 0.83 minus 6.23 divided by 25 minus 1. Okay, 0.83 minus 6.23 divided by 20. Okay, negative 0.27. Oh, sorry, 0.83 minus 1.83 divided by 20. Okay, negative 0.05. Okay, if this model for the population remains valid, how many whole years for the population of the fox first decrease to 1,000? Population is P 7,000, P equals to 7,924, e to the power of negative 0.05, okay, to the power of n. Okay, decrease to 1,000, so means 1,000 equals to 7.924, e negative 0.05 n. Okay, so switch over, divided by 7.924, that should be 1. 1 divided by 7.924, okay, so e to the power of negative 0.05 n equals to 0.126. 1. Okay, so negative 0.05 n equals to ln answer, okay, divided by negative 0.05. Okay, 41.4. Okay, after how many whole years? Okay, so 41.4, so log of 42. Okay. Okay, question 12. Show that ddx ln 2x over 3x squared equals to 1 over 3x cubed minus 2 ln 2x over 3x cubed. So notice that top and bottom is a function, so that means this is going to be quotient rule. ddx is equals to quotient rule 3x squared, okay, 3x squared multiplied by 1 over 2x multiplied by 2 minus 6x multiplied by ln 2x. Okay, so equals to this part 1 over x, 3x over 9x4 minus, split them out, 6x, 6x ln 2x over 9x4. Okay, simplify 3 and 9, 3x and x cubed. So 1 over 3x cubed minus 6 and 9, 2 and 3. Okay, x and x4, x cubed. So 2 ln 2x over 3x cubed. Okay, sure. Okay, part B, integrate ln 2x over x cubed. Okay, so to do this question, okay, what I'll usually do is just to integrate what I just differentiate. Okay, so I'll write that down. Integral of 1 over 3x squared, is it 3 squared? Or 3x cubed minus 2 ln 2x minus 2 ln 2x over 3x cubed dx. Okay, and this is going to give me what I just differentiate, which is ln 2x over 3x squared. Ln 2x over 3x squared. Okay, so analyze what the question wants. They want ln 2x over x cubed. Okay, so that means that okay, this question is actually quite simple. Okay, so left hand side we're going to separate them out into this situation. Ln integral 1 over 3x cubed dx. Okay, minus 2/3 integral ln 2x over 3 over x cubed dx. Okay, equals to ln 2x over 3x squared. Okay, now and then I'm going to switch sides. Okay, what do I mean? Because this right here is negative, so I'm going to shift this over to the left hand side, and then shift this to the right to the right side, and shift the ln 2x over 3x squared to the left hand side. Okay, so then I'll get something okay like this. So I'll get integral of x to the power of negative 3 dx minus ln 2x over 3x squared. Okay, equals to 2/3 integral ln 2x over x cubed dx. Okay, so I make things positive, right? Make the thing that I want to be positive. Now, I only need this, right? So the 2/3 can go away later on. Okay, but for the 2/3 to go away, right? First, let's simplify our left hand side so that things don't get so messy, right? So integral of negative x to the power of negative 3. Okay, what do I get? Power increase divided by new power. So x negative 2 divided by negative 2 multiplied by 1/3. Okay, minus ln 2x over 3x squared. This one has no change. Okay, then plus c, right? Equals to 2/3 ln 2x over x cubed. Now switch back the sides. Okay, we'll have integral ln 2/3 2x over x cubed. Okay, so we'll have negative 1 out of 6 divided by 2/3. So negative 1 out of 6 divides by 2/3. Okay, so we get negative a quarter, x to the power of negative 2, so x squared. Okay, minus this will be 3 ln 2x over oh wait, so this is okay, there's a 3x squared, so it will be ln 2x over 2x squared plus c. Okay, so that's my answer. Okay, yes. Now, see, given that the curve passes through the point half and 1 and is such that f prime x equals to ln 2x over x cubed, find fx. Okay, so that means f prime x is equals to this. The integral of this ln 2x over x cubed is going to give me okay, is going to give me fx. So equals to negative 1 over 4x squared from the above, right? 4x squared minus ln 2x over 2x squared plus c. Now they say passes through half and 1 means what? When x equals to half, fx equals to 1. So 1 equals to negative 1 over 4 times half square minus ln 2 bracket half over 2 bracket half square plus c. Right? So c equals to, right? So this side is going to be negative 1, right? 4 times 1 over 4 is 1, so it's negative 1. Ln 1 is 0, so this side is 0, so plus c. So c equals to 1 plus 1, right? 1 plus 1. Okay, so okay, let's slowly. Okay, so it's 1 equals to minus 1 plus c. So c equals to 2. Therefore, fx equals to negative 1 over 4x squared minus ln 2x over 2x squared plus 2. Answer. Okay, question 13. The diagram shows a circle center O, points A, B, D, and E lies on the circle. The line AD is a diameter, DCB is a tangent at D. Line EB and AD intersect at O. Okay, intersect at Q. Right. The chord AB is produced to be the tangent at P. Given that CPB equals to angle DEB, show that angle BCD equals to 90 degrees. So what I'm focusing on right now is looking at AD. Okay, so AD is travel towards B. Right. So angles in a semicircle, angle ABD equals to 90 degrees. Okay. Now, second information, CBP equals to angle DEB. DED is this angle down here. CBP is this angle down here, and they are the same. So then I'm saying that let angle DEB be equals to x. All right. Hold on, let me charge. Okay. Now, if this angle is equals to x, so this is x, this will be x. Now, and there will be a lot of angles that will be x as well, right? So such as angle DAB is also equals to x. Okay, so let's label this angle as x. Okay, so therefore angle, because it's angles in the same segment. Okay, we have angle BDC also equals to x, because alternate segment. Okay, this is also x. All right, so angle ADC is equals to 90 minus x because of tangent perpendicular to radius. Okay, so we'll have this angle as 90 minus x. Okay, so angle BCD, right? BCD is this angle down here. We want to prove that it is 90 degrees. So now okay, from the triangle BDC, we know that BDC is x. Okay, but we can also see that angle DBC is equals to 180 minus 90 minus x. So it's 90 minus x. Okay, sum of angles, angles on a straight line. Angles on straight line. Okay, so this is 90 minus x. Then therefore, we can conclude that angle BCD is equals to 180 minus x minus 90 minus x, which is 90. Sure. Okay. Okay, show that dp squared equals to bp squared plus dA times bc. Okay, so usually this kind of question is something times something. That will be similar triangle. Now, because of the plus, okay, let's take a look at the triangle. Okay, the plus is a little bit suspicious, right? So I'm going to do this. Okay, copy. Okay, so I don't need to keep turning around. Okay, I mean scroll up and down. All right. So imagine like this. All right. So dp squared. Where is dp squared? So dp squared is down here, equals to bp squared. Okay, bp squared plus dA times bc. dA times bc. dA is over here times bc. Now, what are they trying to say over here, right? So from the looks of it, okay, the two starting one, okay, maybe I change the color a little bit. Okay. From the looks of it, this pink line is something to do with Pythagoras. All right. So Pythagoras wise, it will be, okay, based on Pythagoras, it will be bd squared plus bp squared equals to dp squared. Okay, now we have this condition, dp squared equals to bp squared. Okay, so the only thing is the bd squared. So that means we need to find a link between bd squared. So we want to prove that bd squared is equals to dA times bc. Okay, so split to one side, bd, that means adb and bcd will be involved, right? If I were to prove a similar triangle down here, because of the square, right? If we distribute, that means dA will be tagged to bd and bc will be tagged to bd as well. dA over bd over bc, sorry. And bd will be tagged with bc as well. All right, so then that means that we are focusing on two triangles, triangle ADB and triangle ADB, which is this triangle, versus triangle BDC, okay, versus triangle BDC. So we want to form a similar triangle between these two triangles. Okay, look at it, they are indeed similar, right? Okay, so we can also conclude that they are actually parallel, right? Because it's 90 degrees. Okay, but not the main point. Let's do the similar triangle. We can say that based on similar triangle, ADB, triangle ADB is actually similar to triangle BC. So we have AD over BD, DB is equals to DB over BC. Okay, so DB squared, or rather BD squared, equals to AD times BC. Okay, which is the condition down here. So rearrange a little bit, DA times BC. So DA times BC. Okay, so based on Pythagoras theorem, okay, DP squared is equals to BP squared plus BD squared, which is equals to BP squared plus DA times BC, because they are equal. Okay, they are equal down here. So then, therefore, we have shown, right, BP squared. Sure. That's all.